Hello, everyone. My name's Adam. I've been a design engineer with HBK for a little bit over going on 4 years now. And I'm here today with Randy and Bob. And we're going to talk to you about engineering and sensors and a few questions around those. Randy, Bob, would you like to introduce yourselves?
Thanks a lot, Adam. Yeah, I'm Randy Hopkins. I've been with the former HBM, now HBK, for 33 years. Started off in design and development, just like yourself, and it's kind of moved along in my career and taken on more of a leader for our business unit for OEM sensors.
All
And
right.
I'm
Well,
Bob Chevalier. I've been with the company for 20 years, just after the internet was invented, before cell phones, pager time. And I'm director of OEM Sensor sales and have been working with Randy this whole time to help build this group and get these strain gauges into as many applications as possible.
all right. Well, thank you guys both for being here. I'm happy to be able to talk with you today. To start, I'd like to get a little bit of some background on you guys and just kind of chat about that. So as a starting question, where did you guys get into engineering and sales? How did that start for both of you, and what was that like at the beginning of that process?
I mean, I could say from my side, I mean, it almost started for me before I came to HBM. I was at a company called New England Instruments, and we did potentiometric sensors. And I started off there, same kind of a role, design and development, and became the engineering manager. And slowly but surely, I got integrated into the sales team as we started doing new product development. And it when I made the move to HBM, it was almost like the same career path just started all over again. What about you, Bob?
In my case, yeah, I was a true disappointment to my family. So I was in pre-med and came out with a chemistry degree and decided to play music for a number of years. And then when that didn't work out and I had a lot of babies running amok, I had to find a real job and found that I was more of a person that liked to work applications than do engineering work. And I found HBM at the time a real novel kind of company. I had been in sensors and data acquisition just a little bit before that. And the strain gauge and load cell sensors are kind of really unique in the sensor world versus temperature controls. I was in that kind of temperature and stuff like that. So it was out of necessity I came to HBM because I had a lot of kids looking at me at the time.
That's great. So both of you guys have said that you've been in this for a while now. I believe 20 plus years on either side.
Yeah,
Uh,
you can change the front number on me, but that's okay.
We have a
Randy, I
combined
know you.
total of 50 years. That makes us almost a senior citizen of just experience.
Yeah, just your time here is already qualifying for AARP and
This counts
getting
at
into
Dunkin'
movies
Donuts.
discounted. Yeah.
I can't
So,
believe you just said that.
so you guys must have seen a ton of stuff come through that's just absolutely been completely done over. So what are some of those technologies that you work with day to day that just are not what they were back when you first started?
Oh, I could start. There's a thing right now called finite element analysis. Back when I started, I hate to admit this, but it was before the PC was even being used. We had back at my very first job, we had a mainframe that did some of the heavy number crunching, but everything was predominantly by hand. I mean, it was hand calculations, it was, doing approximations. And I think the big change is that back then there was more trial and error. So, like, you would have an assumption, you'd have to go make a part and do the experimentation, where today you can do simulations with the FEA and cut out all those steps.
I take it that's something you think has improved the world greatly, right? Definitely.
Well, it's just what it's done is it's speeded up the whole process. If you think about it, if we started a project, 25, 30 years ago, you would first of all, email wasn't even around. You're sending facts and quotations in snail mail, and your communications would be a phone or a conference call, and trying to find a room that actually had a speaker box so that you could have a group talking was a big deal. So it was more traveling, going to visit people, than communications back and forth. And I mean, the big thing when we started doing faxes, that was, kind of making them, to me, that made the communication jump a lot in terms of speed. And then from the fax evolved email, and to what we're doing right now is having a conversation over a video, platform like Teams. I mean, the world has evolved over time.
Yeah, even going from analog solutions like the old scale calculators to those desktop ones that I know you have on your desk, Randy, with the big old buttons. And now we've got a calculator built into our computers, one on my phone, and more power in my pocket than used to land a rocket ship.
I mean, I can go back when we had to go visit a customer, and it was always print out the directions, or you had to go through someone to write down okay, the third lights, take a left and be careful there. It's become before a rotary. And nowadays it's, what's your address? Yeah, I'll be there. Okay, it says I'll be there in 52 minutes.
But Randy, from the engineering side, what I found when these technologies, these disruptive technologies came in, and I will talk about that and not FEA. I would say when Microsoft Word showed up or Excel, in my day, in our day, if you had a proposal or a contract that had to get out, we would handwrite it and give it to actually a secretary. They were actually called that at the time, and they would type it, put it in a word processor. Some of the the IBM typewriters would have memory built in, and they would correct that, or then you'd make a correction, and then they would get it. And then, like you said, when the fax came out, so I'm wondering, did you I vaguely remember at HBM you had the drafting tables. So did you have somebody designing the load cell and then in giving it to, I remember there were just draftsmen, all they did was draw. But now with the
Yeah,
new
that's
technology, not only do I had to learn to type, right? And it's never gotten past, the two finger type thing. So it's like, well, wait a minute, man. Now I got to make sure that the English is correct in the contract, where never before I had to really work that. So was that the case with? Yeah. Okay.
yeah, because basically what we would do is, I talk about like a lot of hand calculations to do for the structures, but to get the shapes, the fits, I mean, we had all kinds of, there were basically tables that would, classify different tolerances in terms of the fits that you were looking for between slip, force, etc. And what we would, at least what I would do, would be on my drafting table, I would kind of sketch out the basic design. And then at that point, like you said, Bob, would pass it over to a drafter that would then dimension it, and they would then take it off to the next level. And then I would get a bunch of drawings back where I could look at all the dimensions and basically do a check to it. And this is back when we used to use those the boxes on our current drawings, whether they were drawn, checked, approved. I mean, you had all kinds of signatures in those bottom boxes as they went through all the people to ensure that everything was what it was supposed to be.
Yeah, I had something the other day where I had to look up one of our old clamping fixtures, find the old drawings for that. With some help from some other people on our team, I was pointed towards where we keep the old drawings and pulled out this old drawer full of drawings from. I think the oldest one I found was 1974.
Oh,
And you open the drawer and you just get hit with this wave of graphite smell that now it's printer ink. And you almost lose that little bit of nice, almost artistry to it. It's got like
Yeah.
that earthy scent. And
No.
you look at these old drawings and you don't realize that these perfectly straight lines at first were done by somebody sitting down there with a pencil and basically a ruler.
Yeah, there's a technique we learned how to do that, as far as how you had to turn your pen as you were rotating so that you didn't wear the lead on one side, and it kept everything consistent.
I was jealous of the way you learn. I remember taking a how to print properly, and how to draw an S. And then I was jealous of all their templates. They would have all these green templates so they could quickly write their letters out. And because it was beautiful, the print, but my gosh, the time it took.
Yeah. It was just like like all of a sudden right now today, if I asked Adam to do a fixture or a jig, he can literally do it in the computer, print it off. We can even transmit it electrically down to the NC machine if if everything was how you want to do it, and spitting out a part where in the past it would be someone would make a sketch of what it was, hand it to drafting. Drafting would have to draw it up. You'd have to check all the dimensions because now you're passing what's in your mind to someone else to create on the drawing, where nowadays it's coming right from your mind to the print.
Even on that, with the new 3D printing technology that's out there, I can send a part to be made from my desk that I will never touch until it is entirely completed, and it is entirely automated at this point.
Mm-hmm.
Randy used to have to whittle it out of bathroom soap, and
Wow. That hurt, Bob. That hurt.
So that does spin into another great topic: is how has prototyping developed in the years? It must have been much slower back when things were being done by hand.
There was many more iterations. Okay. It was a lot of things that you would, how do I want to say, you'd be making way more parts to all of a sudden maybe uncover, like, say, a structural problem. And that's why you always did proof loading and things along that line, is because when you're doing your hand calculations, you're really only, it's rough, it's in certain areas. It's not necessarily finding every little point of where there could be a problem. You're using basic assumptions in order to calculate in certain areas, and then you go make a prototype. But then once you have the prototype, that's really your first full structural test that you can do, and then load it in all different planes to see what's going on.
So speaking of sort of prototype design and this old style of iteration upon iteration upon iteration that has kind of weaned down more recently, um, can you speak of any really nice designs that you found through that process? Any nice, just little things that you think were really neat or clever or well thought out that you can talk about?
I mean, this some stuff that I've done with some SL type designs. I mean, one of the first things that I did back in the 90s was came up with a sensing section that, I mean, we called, I don't know if I can claim fame to it, but I mean, it was something that where I took, instead of having a round hole where we're coming in and doing the bending stresses on in a circular shape, we went to an oval. And the reason I went to the oval was this is when I started looking at, I mean, it goes back to what Bob said about some of these Excel tools that came into play that allowed me to start to evaluate certain patterns a little quicker than just doing simple hand calculations. We kind of brought it up to where I could do maybe some limited iterations to see different patterns. And what I started identifying is that by flattening it off or limiting your peaks from end to end over the strain gauge, we could actually affect the performance in terms of, basically flatten everything out. So you were looking at what I would call pure bending stresses on either side of your central loading point, and not having the peaks allowed for a little bit of error from the load input and really not affect any of the performance.
Bob, you got any fun stories either, as well as Randy's, of just neat, problematic things that you've come across in sales and been like, wow, how did engineering figure that out?
Oh, constantly. And I'm trying to remember back in the day that we didn't have as many applications as we do now. And I'm trying to figure out what came first, right? So we really led the market with investment in talent and tools at the pace of the market. Because if you ever watch Forrest Gump, before the 70s, before Richard Nixon went out and played ping pong in China, or they gave him a ping pong set, China was closed to us, and and so that enabled a lot of new applications. But mostly in the day, Randy, we were only dealing in scale or weighing business, right? There was very little outside of that at that time. And so with the advent of new applications, in your generation, everything's smart now, smart. Well, that's sensors. So the explosion really started about what, 10, 15 years ago, that's really created the need for Randy and his group to come up with novel and new ways. And I'm blown away every day by just think of bicycles, right? Power meters, and that started Tour de France, what, 20 odd years ago. They're starting to add these power meter things. Everybody's got them on a bike now. Every exercise bike has a power meter in it, and that's a strain gauge sensor. And now with e-bikes, we got this haptic sensing thing going on where you're going to just, you're pedaling. You don't know if the motor's going or it's your legs are pedaling. It's truly amazing in just the breadth of industries we're in, but and then the abilities within those industries, or the technology within those industries. You name an industry, and I got a story about it. It's been a real honor to be able to watch this growth. I was talking to some people yesterday saying, my generation created hard drives and data. Okay, your generation is figuring out what to do with the data. Okay, and and we're such a major part of that. Just talking on the e-bikes, Randy, you can talk about all the stuff we've invented and done in that area.
Yeah, I mean, it's not only just that area. It goes back to some of the things you touched on. Like when I first started, everything was basically weight. Okay, because now what they're doing is you're looking at, okay, what do you need weight for? So it comes down to someone needs to ship a product. So you've got all the shipping companies are charging by weight. And then it evolved to now you've got, shampoo bottles, you've got all these different items that we're all buying commercially are now, if you look at their boxes, everything is done by a certain weight or a certain, um, terms of some type of a measurement. And so everybody had to figure out, okay, well, if I want to maximize the value of my product, I got to be as close to that weight, without going significantly over, or I'm giving profit away. So everybody looked at improving the industry in order to measure that type of stuff, and that's where it was all weight driven. I mean, if you go to, even in the medical field where they're just giving people prescriptions by their weight. Typically, you walk in to get your physical, they tell you to stand on a scale. Well, I remember when that scale was a bunch of weight things that you adjusted to figure out what you were going to be because it was a balance. Nowadays, I go in and a digital display pops up. So it's evolved away from the old lever balances to actually a digital scale. But then you evolve that, and now you got somebody in a hospital that can't get out of the bed to take their weight, and they want to monitor this for different, prescriptions that they have to, or different medicines that they're going to need. So now you turn around and say, well, how do I get that weight? I turn around and I make the bed a weight sensor. And so that's one of the first evolutions where you started turning around and saying the problem of the world was they needed this information. Now, how do you get it in a most, obviously economical, but without being a hindrance to what you're trying to, or why you're trying to get it? So in this case, you may have a patient that's bedridden. You can't literally get them up. One of the first things was come in with, remember these cradle things where they come in and they, come over and have this sling that would pick a person up out of the bed so that you could get the weight measurement. I mean, it takes 2-3 people to orchestrate that whole move. But if you have the weight sensor in the bed itself, now someone comes over, hits a button, and next thing you know, you have the person's weight. So it's how the things, the information is evolved over time on what we're looking for and how we're getting there. Like you talk about the bike stuff, Bob, the way you described it is perfect. And there's a lot of other industries in terms of, when people are trying to get what I'll call force feedback now. It's not necessarily weight, but it's more getting a force value to make a decision or to give a red light, green light to some type of an operation. And it can be endless now. And the more the world tries to go smart or tries to go, you know, integrate what I call control loops into their product, this is when they need sensors that we can go create. And that's part of our group.
And
When we
I,
were
I think
speaking,
at least, sorry, go ahead, Rob.
I'm sorry, when we were speaking to a large application the other day, we said, well, what are you going to do with that data? And he goes, we really don't know yet because we've never seen it before. We've never measured. We think we're going to be able to see it this way and it's going to provide this information, but we've never got recorded that data. And it's so fun for us because, as he mentioned, the scale, but that didn't become as important as somebody falling out of the bed. So we were able to use those same sensors to do center of gravity calculations and same sensors to actually do motion detect. So all these added benefits by adding this sensors that nobody anticipated in the very beginning, it's really fun to watch how this information is being used when it was never contemplated before.
Right. I mean, if you turn around and just take a totally different industry than what we've talked about, and I was just sitting here thinking while you were talking, Bob, that like you got like the Indianapolis 500 or the NASCAR stuff down in Daytona. They've now got these engines, so it's not like you have this one engine that's got so many more horsepower than the other one. Okay, they've really equalized themselves. And I guess in NASCAR they have what they call restrictor plates so that they can control what's coming through there, et cetera, et cetera. So now, in order to be the quickest, you either have to be the super driver that understands everything of where to be on that track, but it also goes down to how you set the cars up. I don't know if you've ever watched some of these, 10, 12-second pit stops, but they're running around, and as soon as those tires come off, I'll see it in the back as the car's peeling out. People are taking probes, they're looking at tire temperatures, they're looking at the pressures, they're looking at all this information, and it all flows into some type of a data acquisition system, and they're analyzing it. And what we do, think of in terms of setting the car up or how do you balance it or what you can do. You need sensors to give that information or give that force feedback of what's happening, say, in the suspension systems of these cars. And this is the information that we're providing. Again, is this life saving like in the medical industry? Probably not, but I'm sure if you talk to any pit crew or owner of they're trying to get every piece of information possible to be ahead of the competition. And that's kind of what we're set up to do. Now, if you ask me what will we be doing in 10, 20 years, there'll be other aspects that will pop up in terms of people are going to require information. And that's what we are. We basically are the source of this information so that they can then feed this back and create a control loop so that the product becomes either safer, faster, more economical, better for the world. And that's the stuff that we bring to the marketplace.